3, we have a 200 kilogram boat moving at 3 meters per second. It's going to strike an 800 kilogram boat floating at rest. And what we're going to try to find is the final velocity for this 200 kilogram boat after they collide. So once again, we're going to draw the initial and the final. We want to draw the initial and the final as these boats collide, before they collide and after they collide. Because what we are saying is that momentum before is going to equal to this momentum after. This momentum is going to be conserved. We have one boat moving to the right. It's going to strike this boat that is remaining motionless, and that's going to cause the boat on the right to move to the right. We don't know what's going to happen to this boat here. We don't know if it's going to move to the right, move to the left, but we can solve for this final velocity. We do know that momentum before will equal momentum after. So we know that 200 times 3 plus 800 times 0 is going to equal to 800 times 1 plus 200 times the thing we're looking for. So if you can already set that up in your head, you're off to a great start. But we draw out the before, after, we add in all the conditions for this, leading us to what we're trying to find is the velocity of that boat number 1 or boat A and the final velocity for that. So the way we're going to set this up is momentum before equals to momentum after, where this total momentum before equals the total momentum after. This momentum of the system is being conserved. We know that boat B or boat 2, the 800 kilogram boat, was motionless initially, so it has no momentum before. So all that momentum before came from the 200 kilogram boat. Afterwards, the 200 kilogram boat is moving and the 800 kilogram boat is moving, and we know how fast that 800 kilogram boat is moving afterwards. So you could set this up right here. So I put this dashed line because you could do 200 times 3, and you get 600. That's the total before. So everything that is before is equal to 600. So after, there has to be 600. We know that mass of this second boat is 800. It's moving with 1 meter per second. So we know that there's 800 here. 800 plus something has to give us 600. So we know this plus something is going to have to be just 200. And if we divide out by the mass of 200 kilograms, then we know we get our velocity of 1 meter per second. But now we can prove it mathematically as well. So once again, what are we trying to find? We're trying to find the velocity of the first boat or boat A. So I try to make it clear what it is that we're trying to solve for. So by solving for that, move everything to the other side, including the mass, and then you just type in those variables just like how we had, and it gives us that negative 1 meter per second. So in your document, you can give me the velocity of boat A final or the velocity of boat 1 final. Really, this is all I need for us. It's telling me you're finding a velocity, what it's equal to, the positive or negative, tell me the direction, the number, and the units.